This is our Sun, our entire solar system, stretching all the way out to Neptune, the most distant planet from our star. And out here is the heliopause, the boundary where the Sun's solar wind finally dies out and interstellar space begins. And this enormous, almost unbelievable object, that's Ton 618, a supermassive black hole roughly 40 billion times the mass of our Sun. Huge, right? Well, not compared to this. This is Phoenix A's black hole, an absolute cosmic titan weighing in at 100 billion solar masses. Not just black holes, but the largest stars, the heaviest planets, and even entire galaxies. Things are about to get explosive. To understand what happens when black holes collide, you first have to grasp their scale. On the small end, we have stellar mass black holes, the collapsed remains of massive stars that have burned through their fuel and imploded. They're so dense that not even light can escape their gravity. A stellar black hole can be smaller than our moon, yet 100 times more massive than the Sun. On the opposite extreme are supermassive black holes sitting at the centers of most galaxies. Take one of the smallest known supermassive black holes, J1601 plus 3113. It's roughly the same diameter as our Sun, but 100,000 times more massive. Travel to the Circinus galaxy and you'll find a black hole over 1 million solar masses, large enough to nearly fill the space between Earth and Venus. And at the heart of our own Milky Way lies Sagittarius A, weighing in at 4.3 million suns. But all of these pale beside the black hole in the center of Cygnus A, the strongest radio source in the universe. It dwarfs our entire solar system, devouring matter while blasting out unbelievable energy. This beast weighs over 2 billion suns. Yet even that isn't the biggest. M87E's black hole, the first one ever photographed, weighs more than 5 billion suns. But even M87 looks tiny next to Ton 618, so massive it could swallow our entire solar system past the Oort cloud. Ton 618 is roughly 66 billion solar masses, a true cosmic monster. But scientists have found something even bigger, the black hole in the Phoenix, a galaxy roughly 100 billion solar masses. And still growing, consuming a sun's worth of mass every single week. These objects aren't the result of stars dying last year. They're ancient, potentially primordial black holes formed shortly after the Big Bang. So what happens if Ton 618 and Phoenix A's black hole collide? First, they'd create gravitational waves, ripples in spacetime itself. But don't imagine a car crash. Think more like an elegant, horrifying dance. Place these two leviathans in the same galaxy and they'd begin orbiting each other, spiraling inward over millions of years, pulled together by gravity. Two singularities, bound forever. As they get closer, they distort each other's shapes. Their event horizons stretch like cosmic taffy. And when they finally meet after millennia of orbiting, the final merger happens in an instant. A cosmic bloop, yes, that's actually the best way to describe it. Two of the largest objects in the universe collapse into one unimaginably massive black hole, releasing energy so extreme that gravitational waves ripple across the universe for billions of years. And then, the new black hole simply continues feeding, as if nothing extraordinary occurred. But let's go even bigger, entire galaxies. Galactic collisions are real. El Gordo, for example, is a massive cluster of galaxies smashing into each other with insane force. So what happens when two galaxies smash into one another? Despite the scale, it actually looks less like a smash and more like two ghosts passing through each other. Galactic mergers can take billions of years. As they merge, tidal forces rip stars from their orbits, dust and gas scatter everywhere, and the beautiful spiral arms distort. Most stars won't collide, space is simply too vast. On average, stars are 5 light-years apart, that's about 29 trillion miles. So while the collision is dramatic, actual physical impacts are rare. Still, they do happen. So let's talk about planets colliding. Meet Toy 4603b, similar size but nearly 13 Jupiter masses. These are the sumo wrestlers of the cosmos. If they collided, the impact would be the biggest gas giant wump in history. Their hydrogen atmospheres would blast into space, and they'd merge into one giant object. But here's the twist: the combined mass would push them past 13 Jupiter masses, the threshold at which a planet becomes a brown dwarf, a failed star. Brown dwarfs can't sustain hydrogen fusion, but they can fuse deuterium, giving them a faint infrared glow. And if they gather enough mass, they could eventually ignite into full-fledged stars. But speaking of stars, what happens when two of the largest stars in the universe collide? Let's take BAT 9998, a massive star in the Tarantula Nebula, over 200 solar masses and 5 million times brighter than the Sun. Replace our Sun with it, and Earth wouldn't last a day. Our oceans would vaporize instantly. The crust would melt, and we'd be swallowed whole shortly after. It is similar in size to Eta Carini, a luminous blue variable star powerful enough to carve out the homunculus nebula around it. It even produces an ultraviolet astrophysical laser, the only known star to do so. So, if these two megastars collided, two possibilities. 1. Low-speed collision. They merge peacefully into a blue straggler, a younger-looking, brighter star with tons of fuel. 2. High-speed head-on collision, total annihilation. An explosion so violent that both stars are shredded beyond recognition, scattering their hydrogen across space, never to form new stars again. No graceful dance, no cosmic bloop, just obliteration. And speaking of interstellar space, have you heard of the Interstellar Object 3 Atlas? It's passing through our neighborhood right now, which raises the question, what if it hit Earth?